In this video, you will see Julian and Alyssa working on the following problem. Vicky took 400 milligrams of ibuprofen to relieve knee pain. The amount as a function of elapsed time is f of t equals 400 times 0.71 to the t. Their task is to approximate the rate of change of the amount of ibuprofen in Vicky's body with respect to the number of hours elapsed when t equals 4. As they work, consider the obstacles they encounter and think about how you might solve the problem.
So t equals 4 is like here.
Yeah.
So at that point.
Great. So what I'm thinking is let's take a t that's one smaller and then t that's one bigger, and do like the change of y and change of x. So we could do so if we have this, we can use, oh, I'm sorry about that. It's a 1. So if we use this kind of formula, we can do t equals 3 and t equals 5. And that way when you do it, you would get.
Okay.
And then get that slope.
Mm-hmm.
And I think that's it'll be something along the lines of like, let's see if I can like that.
Mm-hmm. Yeah, I think that'll be a good approximation. But like, could we make it better by making it like a smaller, like intervals? Maybe like we could do like 3 to 4. Like
Maybe.
I don't know if that would. It's kind of not good at drawing these lines, but I guess that looks like way too steep now.
Yeah. That might be too steep. Like if we did 3 and 4.
I guess it'd be the same with 4 and 5, but it'd be less steep
Yeah.
than what we want.
So I'm thinking like if what we had was like, I don't know if it'll be like, I don't know if it's too high, but I also don't know if it's too low.
Mm-hmm. So like, how can I get a more accurate like approximation?
Mm-hmm.
Like
Without having it be
without
so steep or.
Yeah.
Okay, so so we've said so far t equals 3 and t equals 5, but we also said t equals 3 and t equals 4.
Mm-hmm.
And we want to get we want to be as close to 4 as possible.
Yeah.
So like, could we possibly do something like I guess like t equals 3.9?
Okay.
And then it's like we'll do like t1 equals 3.9, and then like t2 equals 4.1,
Mm-hmm.
because then that would get us something like there, and then we would get
Be a lot closer.
which would get us this line here, which seems a little bit more accurate than
Yeah.
I guess the larger intervals.
Mm-hmm.
So I guess like the smaller the interval, the more accurate it could be.
Yeah. But like, how small do we need to make it to make it?
Like, do we have to go smaller than this?
Mm-hmm.
We might.
I mean, like, we could always make it go smaller. That was the issue.
In this video, Julian and Alyssa tried to approximate the rate of change at t equals 4 by using average rates over small intervals, but they weren't sure whether their answers were accurate enough. We'll explore how to think about this problem in upcoming videos.